And thanks for giving me the floor, Benjamin. I am here, as the other speakers, to talk to you today about 3D printing, and that with a different point of view and perspective from the previous speaker, because he came from the Commission and mentioning what the challenges lie ahead for his part of the Commission. And I tend to agree with what you've said, with a few exceptions, but we'll go into that. To some extent, and I regret this, I'll be talking about some of the topics that you've mentioned already, but I guess that if our minds are aligned in there, that's a good thing and not a bad thing. What's 3D printing? 3D printing is this. 3D printing is developing a device that allows rescuing the life of a baby born in Michigan, US, 2-3 years ago, and was born with a severe health problem that caused him to stop breathing from time to time due to a collapse of the trachea. We developed, in collaboration with a local university, a tracheal splint and 3D printed it specifically to the anatomy of this baby in a bioresorbable material that allows this baby to breathe again. The bioresorbable device will disappear in the body of this little patient and until he grows to an age where he can breathe by himself. 3D printing is this. It's the gun. It's the gun. We're always confronted with the gun whenever we come and share the story of 3D printing. It's unavoidable, it seems. A gun is, yes, it can be produced with 3D printing. Is it a wise application of the technology? We don't think it is, but that is the point of view of our company, where we apply a very strict policy in the company to refuse any application of our technology for the development or the production of any weapon, wherever and whatsoever. But it is there, and it's going to be there, and I guess that with weapons manufacturing also come questions of safety, and I'm sure the Commission will deal with that. We have developed 3D printing in the past 24 years. Materialize, a company that I work for, was incorporated in 1990, and from the very start of the company, we have invested massively in research and development. And that is also thanks to the European Union, thanks to policymakers, also the Belgian government, that has helped us significantly. If you see there in millions of euros, the amount of R&D invested in Materialize and the amount of support we have received through funded EU research projects, that is significant. But what is it? What is 3D printing? 3D printing is different from classical ways of manufacturing in that it does not work from starting from a solid piece of material and then working your way down to the product that you want. It works the other way around. It works so that you can start from a raw material that is a powder or a liquid or whatever, and you build it up layer by layer. And that's how you come to a new product. And why would you want to choose to additive manufacture or 3D print your product? Why would you want to do that? We think that there's 4 reasons. One reason is you can make great stuff. You can do beautiful things. You can save the life of a baby. You can also, in a very different industry, in the fashion industry, you can start thinking about dresses that before could not be conceived, could not be manufactured in a classical way. You can make products at a very low cost. What you see here is a picture of hearing aids. The hearing aid industry, in fact, is one of the first industries that we are aware of that made the switch entirely to 3D printing or additive manufacturing, I think 3 to 4 years ago. And that is an evolution that has taken place over years, but any hearing aid on today's date can reasonably be assumed to have been manufactured with additive manufacturing technology. And that is simply because it allows for so much more functionality. It allows for an exact fit on the patient. We think that 3D printing is a good way to manufacture a product, okay? Because it allows for certain advantages to manufacturing that classical manufacturing will not have. The bloom there that you see is an example of a lightning object that we have made. Another example is this chair that comes out of the printer like this. It comes out of this. We printed in a couple of products of these in one build, but in fact it is a chair that when unfolded you can perfectly sit on. And so what 3D printing allows for is really manufacturing with functional elements of your product inherent in the manufacturing process so that it does not need assembly whatsoever, which also adds to the uniqueness of the product that we manufacture. And I think unique is a word that also applies to this object, which is a device, a medical device that we have had manufactured with metal printing, where we have helped to reconstruct facially a person's face that was heavily deteriorated by a cancer. And so we helped reconstruct the face of this patient specifically to the needs of that patient. How do we do it? And in all its simplicity, this is an important slide. 3D printing is much more than pushing a button. Yes, you can buy a 3D printer online on today's date, but before you can manufacture a product that has to meet certain quality requirements, that has to be safe, and that has to have the qualities and the quality that you want it to have, you need to have much more than just the printer. You need to have people that know what they need to do when designing a file, when designing a product, that know how to design a product so that it can be manufactured by additive manufacturing technology in a safe way. You need the printers, you need the material to manufacture it, and then you need the people to post-process also your product, because it doesn't come out of the machine like this. It needs some finishing. It certainly, and that is even more important, it needs, prior to pushing the button of the 3D printing, it needs engineering. I'm going to make another example. This is a 3D printed patient-specific hip implant. This is a print of an elderly patient's hip bone. And normally, for those that have no medical background, this is full. This is bone also. So this was a patient with a severe hip bone defect who was no longer walking because she or he was unable to. What we did is we print from the medical image data of this patient, we print the bone model, and then we start engineering an implant. Printing this implant will require 5 hours. Designing this implant takes 95 hours. And that is because you need the engineer, you need good quality medical image data, and then you need a lot of interaction between the engineer on the one hand and the doctor on the other hand, so that in the end you come to something that will work, and that will work for a longer period of time than a classical manufactured implant, and that will also guarantee a safe product for the patient, obviously. And I think that if we think about challenges for 3D printing, then I think that that is where, in fact, the bigger challenge lies. It is in everything that we do, quality is at the center. Whether it is developing a dress for a fashion designer, whether it is developing a prototype of a new car or of a plane engine, whether it is developing a medical device such as this one, we need to have, and we need to be able to guarantee to our customers, whomever they are, we need to be able to guarantee a certain quality of level. So what does this mean? From policymakers' point of view, we think that 3D printing has a great opportunity of stimulating local entrepreneurship because it's low cost. If you are an engineer, if you are a product developer and you have developed something that you think is really worthwhile manufacturing for the whole wide world, you just need to make sure your file is ready, throw it on a platform such as an iMaterialize or a Shapeways platform, make it available online, and there you are, and you can start up a business. What you see here is prints of a train, a model train, that simply an individual in Germany started together with us to turn his hobby into a profession and really start offering for sales the miniature trains he had been working on. Second big challenge, you need to think about medical device regulation. And there is a regulation that has been adopted which causes us great worry. In the bundle that you have received, there's a position paper that we have added for those people that would be interested, because we really believe that the legislation on medical devices is not guaranteeing safe usage of additive manufacturing technology in the years coming. And there's a lot of work that needs to be done to make everybody understand what I said before, and that is that 3D printing is so much more than pushing the button. Last thing, and this was addressed already by the previous speaker, is of course the question on copyright. What you see here is a Super 8 cube from the movie Super 8 that was developed and that was then printed and provided and commercialized by an individual that reverse engineered the design. The big question that you have, if this person, and he has been sued, is sued by Paramount Pictures, what is his story going to be? What is his defense going to be? Can he do this, yes or no? Should we protect copyright, and at what cost and to what extent? I think that these are three of maybe the more important challenges that we have identified so far. There's many more, of course, but I'm sure that we'll touch on some of them when we go to the debate. Thank you for your attention.